All right, this last problem is, it has a lot to it. So I'm going to do my very best to do my best handwriting. I apologize in advance. Definitely go to page 185 in your textbook and look at this picture. I have a very rough sketch, but it shows you a lot better what's happening in the book. So on page 185, we have the 7-inch connecting rod. Obviously, that's a constant because it's a rod. And it's fastened, sorry about the typo, to a crank of radius 3 inches. And that's also a constant. So the crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute, and we want to find the velocity of the piston when theta equals pi over 3. Again, look at the picture, you'll see better what's going on. So the things that we are given here, obviously our rod doesn't change. The radius of this thing is 3, and we know that theta is pi over 3. And then we're also given the rotation of the crankshaft. It's revolutions per minute, so that is our d theta dt. So 200 revolutions per minute. Now, we're going to need to do some trig with this, and we don't talk about revolutions per minute. We talk about radians. So we're going to convert this to radians. So 1 revolution, so 1 trip around the circle is 2 pi radians. So when we make that conversion, we're actually changing at 400 pi radians per minute. And that's going to be better when we start working with our trig. So those are our givens. We are supposed to find the velocity of the piston. And again, when you see the picture in the book, you'll see that the x is actually the piston. So we're supposed to find dx dt. Okay, so now we need the equation that we're going to be working with. This is not a right triangle. Okay, so we know 2 of the sides and 1 of the angles, that theta, so we have to use law of cosines. If you can't remember law of cosines, it should be that inside the front cover of your book with all of those derivatives on it, the back side of that has all of your trig stuff, and law of cosines should be there, also the pink paper I gave you. But law of cosines, remember it's the angle across, there's a cosine of the angle, and then the side across from it goes on the other side. So it's going to be 7 squared equals 3 squared plus x squared minus 2 times 3 times x times the cosine of theta. Okay, so if you want, you can kind of clean that up a little bit. We don't really need to do a lot to it. 6x cosine theta. All right, so there's our law of cosines. I know I could combine a few more like terms, but I'm not going to bother because I'm just going to take the derivative of this. So the derivative of 49 is 0. The derivative of 9 is 0. So we have x squared, so that's 2x dx dt. And then notice this is a product rule right here. So we're going to use the product rule, so we have 1, and then d2 is going to be negative sine theta d theta dt. Remember that's a multiplication there. Plus 2, d1 is going to be negative 6, and then a dx dt. Okay, we need to solve this for dx dt, because that's what we're supposed to be finding. So let's see. I'm going to go ahead and move the dx dt's to the left side of the equation. So that's going to give me 6 cosine theta dx dt minus 2x dx dt equals, now this is a negative times a negative, so that's positive 6x sine theta d theta dt. And then here on the left-hand side, I'm going to factor out the dx dt and then divide. I know I'm skipping a step, but just to save myself a little bit of writing, we get dx dt equals 6x sine theta d theta dt all over 6 cosine theta minus 2x. Okay, we are ready to plug in. So let's see what we know. So we have 6 and we need x. We don't have x. Okay, so come back up here to this triangle that we were looking at. Let's go back to the law of cosines. Basically, we're coming back to this thing. We need to find out what x is. So we have 7 squared plus 3 squared. No. Equals. Sorry about that. Plus x squared minus 2 times 3 times x times cosine, and remember our given is theta is pi over 3. Okay, so we need to solve that so we know what x is so we can plug in. So we get 49 equals 9 plus x squared minus 6x, and cosine of pi over 3 is 1/2. So we get 49 equals 9 plus x squared minus 3x. This is a quadratic. We'll just pull everything over to the right side. So we get x squared minus 3x minus 40. So factor that quick. So we get x equals 8 or negative 5. Clearly that's not going to be a negative, so x is 8. Great, let's keep going. We'll plug in 8. Then we have sine pi over 3 is theta. And d theta dt, remember, was 400 pi radians per minute. All over 6 cosine theta is pi over 3 minus 2 times 8. So this, you can put it all in your calculator. If I do recommend, if you do that you, put the numerator and the denominator in brackets. You can simplify it a little bit before you attempt to do this. I think the answer is negative 4,018. And our units are radians per, no, not radians, because we're not talking about an angle. Inches. Speed is in inches per minute, right? Because it's a 7-inch, and we're in minutes. Yep. Okay. So inches per minute. All right. So we can do these type of related rate problems as long as we have some sort of equation, as complicated as they may be, just relating everything and plugging in what we know.